going to go ahead and start talking about these. Okay? So these are the 4 theorems that you guys just copied down. They should seem pretty familiar, right? Do they almost seem like something we've already done before? Yeah? These are the converse of the theorems we talked about last week. So last week we talked about the same side interior postulate, the alternate interior angles theorem, the alternate exterior angles theorem, and the corresponding angles theorem. These are the converse of all of those, which is another nice vocabulary word, right? We have our conditional, which is an if-then statement, and the converse, you just flip them, which is what they did here. So so if we start here with this first one, theorem 3.4 is the converse of the corresponding angles theorem. So the corresponding angles theorem says if you have parallel lines, then corresponding angles are congruent. Okay, this is the opposite. So you flip the hypothesis and the conclusion. Okay, so this says if you have corresponding angles that are congruent, then the lines are parallel. So like this picture here, okay, we have angle 2 and angle 6. So if angle 2 is congruent to angle 6. Now, here's what's tricky about these ones, okay? When you're trying to prove these and to use these theorems, I cannot use the fact that, okay, yeah, I know 2 and 6 are congruent because they're corresponding angles. Yeah, they're corresponding angles, but here's the thing, guys. Unless you know that these lines are parallel, you don't know that corresponding angles are congruent. The only reason corresponding angles are congruent is because the lines are parallel. And what we're trying to prove today is that the lines are parallel. So what's difficult today is all those theorems that we had, we can't use a lot of them because I have to be able to prove that these are congruent without using the fact that the lines are parallel. So if I can prove that angle 2 and angle 6 are congruent, then I could say, okay, well then L is parallel to M. But I would have to prove that the angles are congruent first, then I can say, okay, the lines are parallel. Theorem 3.5 is the converse of the alternate interior angles theorem. So once again, guys, you can have 2 sets of lines with a transversal, and you're going to have alternate interior angles. Every 2 lines cut by a transversal has alternate interior angles. If the alternate interior angles are congruent, so if angle 4 is congruent to angle 6, not because the lines are parallel, but maybe like use vertical angles or linear pairs or something different, okay? If you know that those are congruent, then this theorem says, okay, if the alternate interior angles are congruent, then I conclude that the lines are parallel. Okay, so it's just the opposite of what we did last week. Last week we were saying, okay, if the lines are parallel, the angles are congruent. This week we're saying the opposite. If the angles are congruent, then the lines are parallel. So the converse of the same side interior angle postulate is saying, okay, if I have these same side interior angles, and once again, guys, you can have same side interior angles without these lines being parallel. Every 2 lines cut by a transversal has same side interior angles. But if these 2 angles, the measure of angle 3 plus the measure of angle 6 equals 180, if they are supplementary, if they do equal 180, then I know that the lines are parallel. L would have to be parallel to M, which is the opposite of what we did last week. And then finally, the converse of the alternate exterior angle theorem would say, okay, if I have these alternate exterior angles, right? And remember, I know I said this like 3 times already, you can have 2 lines cut by a transversal. Those 2 lines don't have to be parallel to have alternate exterior angles, okay? Any 2 lines cut by a transversal has alternate exterior angles. But if these alternate exterior angles are congruent, so if angle 1 is congruent to angle 7, then we know that line L would be parallel to line M. Okay, it's just the opposite of what we did last week. Okay? So what we're going to do is I'm going to try to do a proof every day. This time we're going to do a flow proof, and I'm going to give you guys full disclosure here. Not a super huge fan of the flow proofs. I kind of like parts and ideas of it, but as a whole I'm not a huge fan of it. But you have flow proof in your homework, and maybe it'll click with some of you. Maybe you'll like the flow proofs and you'll want to use them. There's parts that I like about them, but I think overall, I definitely still prefer the two column proofs. So what a flow proof does is we're going to kind of organize, okay, here's what I know. In my picture, here's what I know, okay? In order to prove this, this is what I need, okay? So let's come up with a plan. And then right below it, we're going to actually go through the proof. So what I like about it is I like this part. I like the know, the need, the plan, because we kind of did that yesterday. Didn't we, with that proof that we did? I said, okay, what do you guys notice? What's some information that could be helpful, okay? Well, what's our plan, right? What do we need to know in order to make this proof? Okay, so how are we going to do that? So I like this part, I just don't like the actual proof part, okay? So what we're wanting to do is we are wanting to prove that L is parallel to M, and we're given that angle 1 is congruent to angle 7. This right here is the alternate exterior angle theorem. We're going to prove theorem 3.7 right here. Okay? So, if we start with our flow proof here, okay, the first thing we fill in is the stuff that we know. Okay? Well, the first thing I know would be the given, right? Angle 1 is congruent to angle 7. Angle 1 is congruent to angle 7. Now what we're going to do is we're going to go ahead and just throw like everything out that we know, whether it's going to be useful to the proof or not. Okay? What are some other things that you know off of this picture? You know, angle 1 is congruent to angle 7 because they tell me that. Mark that. Okay. Here's the problem. You're saying angle 3 and angle 5 are congruent because they're alternate interior angles, but they're only alternate interior angles if the lines are parallel. That's what I'm trying to prove. I'm trying to prove that the lines are parallel. Elijah? Okay, now I do know angle 7 and angle 5 are congruent. I know that for a fact because they're vertical angles. And vertical angles don't have to be parallel lines. So I know that angle 5 is congruent to angle 7. We could do the same thing up here, right? Angle 1 and angle 3. I know that angle 1 is congruent to angle 3. Okay, I know that. Now, we could talk about, okay, angle 3 and angle 5 are alternate interior angles. That's not going to be useful. But what's another angle pair relationship that even though I don't know that they're parallel, I can still establish a relationship? Okay, 5 and 6 are a linear pair. 6 and 7 are a linear pair. Let's go with that one. Let's do angle 1 and 5 are corresponding. 1 and 5, angle 1, angle 5 are corresponding. And we could do the same thing with 3 and 7, right? Angle 3 and angle 7 are also corresponding. I don't have enough room in that little box there. Sorry about that. Okay. There's other stuff that we know, but I think these are the things that are going to be useful. Now, the proofs, or the theorems kind of go in order. So in order to do this proof, I could use any of the theorems that I've already learned. I could use theorem 3.4, 3.5, 3.6. We're trying to prove 3.7. Okay? So whenever I'm kind of trying to come up with my game plan here, we could approach this one of a couple of ways. Really either one of these, okay? Theorem 3.4 says, if I have corresponding angles that are congruent, then the lines are parallel. So what we have kind of started is we've started to talk about the corresponding angles, okay? So if I could prove that one of these sets of corresponding angles are congruent, now keep in mind, without using the parallel lines, okay, then I could say that these lines are parallel. So what I need is I need a set of congruent corresponding angles. That's what I need. I need a set of congruent corresponding angles. So I could either do 1 and 5 or I could do 3 and 7. Okay? Let's come up with a plan here. Okay, so this is kind of what we talked to you guys. So what do you think the plan's going to be?
So this is congruent to 5 and 5 is
Okay. Okay, so we know that 7 is congruent to 5, because they're vertical angles. And I know 1 is congruent to 7 because it was given to me. And here's the thing. If 5 is congruent to 7 and 1 is congruent to 7, aren't 1 and 5 congruent? And if I have a set of congruent corresponding angles, the lines are parallel. Okay? So what our plan is, we're going to use vertical angles and corresponding angles. That's our plan. We're going to use vertical angles and corresponding angles to show that they are congruent. Okay, now, I like this part of the flow proof because it's like, okay, we got it, right? We kind of set up what we're going to do. This is where I would like to go into a 2-column proof. But if you're going to do a flow proof, what you do is just kind of below here, okay, under the no box, is you're going to kind of write out your proof a little bit, okay? So I have a whole bunch of stuff in the no proof, but I don't need all of it. So if we kind of go through, angle 1 is congruent to angle 7, I need that for my proof, right? So down below here, this is where your actual proof is going to go. And we're going to say, okay, angle 1 is congruent to angle 7. And just like any other proof, you have to give your reason. And my reason is because it's a given. Okay, angle 5 is congruent to angle 7. Do I need that for my proof? I need that. Okay, so angle 5 is congruent to angle 7 because it is a vertical angle. Angle 5 is congruent to angle 7 because it's a vertical angle. Angle 1 is congruent to angle 3. It's true, but do I need it for my proof? Yeah, that's not necessary, so we need to write it down. Angle 1 and 5 are corresponding. Do I need that for my proof? Yeah, okay. Angle 1 and angle 5 are corresponding. Yes, I need that. Okay. And angle 3 and 7 are corresponding. I don't need that, right? Okay, so I just need those 3 pieces of information. Okay, what I need is I need a set of congruent corresponding angles. So if you look at your proof here, okay, I have angle 1 is congruent to 7, and angle 5 is congruent to angle 7. That could set up my set of corresponding angles, right? The corresponding angles I'm trying to set up are 1 and 5, right? Well, if 1's congruent to 7 and 5's congruent to 7, can't I say that angle 1 is congruent to angle 5? What property tells me I can do that? Remember? Technically with congruency, it's the transitive. Okay, transitive property of congruency. If you're going to use substitution, if you want to get super technical, you'd have to say, okay, if angle 1's, if the measure of angle 5 equals the measure of angle 7, and the measure of angle 5 equals, or the measure of angle 1 equals, anyway, you have to go through and change it to measures and then back into use substitution. So we'll use the transitive property of congruence. Okay, now that I've shown angle 1 is congruent to angle 5, I can now say, okay, these lines are parallel, okay? I can say that L is parallel to M. Because what I've done here is I've shown that, okay, I have these corresponding angles that are congruent. And we have that theorem, what is it, 3-4, that is the converse of the corresponding angles theorem. As soon as you say, okay, I have corresponding angles that are congruent, those lines are going to be parallel. Okay, let's get this glued into your notebook. This is going to be page 37. This is 3-3, and we are proving lines parallel. Proving lines parallel. Obviously, the problems that we've been working with whenever you're talking about alternate interior, alternate x, all of those things, it's using the idea they're congruent because the lines are parallel. we're doing the opposite today, okay? Today we don't know the lines are parallel. We're trying to prove that the lines are parallel, okay? So, first two, we're going to use the picture to decide, okay, with this given information, which lines can I conclude that are parallel? Okay, so number one, all right, so we're going to have lines A and B that are like almost semi-vertical, A and B, and then horizontal lines N and M, N and M. Okay, so diagram looks something like that, and then I'm going to give you a set of congruent angles. So we'll do this angle and this angle are congruent. What I want to do is I want to decide based off that information, because yes, both sets of lines look parallel, and it doesn't matter if they look parallel, if they don't tell me they're parallel, you can't assume they're parallel. But what I may be able to conclude is that since these two angles are congruent, maybe that will tell me that some of the lines are parallel. So what we're going to do here is we're going to kind of look at these angles, and maybe we can decide how would I classify these angles. So these two sets of angles, what do you think they are? They look like alternate interior angles, okay? So if I have alternate interior angles congruent, that's the converse of the alternate interior angle. That's going to be my justification. That's going to be my reasoning. But here's the thing. You have to decide that since these angles are congruent, which set of lines are parallel? I think probably the easiest way to do that is since they're alternate interior angles, the two lines that form the interior are your parallel lines. Okay? So these two angles are interior of those two lines, right? Those are your parallel lines. So I know that A and B are parallel because of the converse of the alternate interior angle theorem. Okay, remember the converse proves that the lines are parallel. The alternate interior angle proves that the angles are congruent. Okay? Alright, number two. I'm going to draw basically the same picture. The lines are just maybe a little bit closer together. Like that, kind of like a skinny little tic-tac-toe. And then we'll name them N-O-P-Q. N-O-P-Q. And I'm going to label this angle congruent with this angle. So those two angles are congruent. So kind of once again, okay, gotta almost ignore kind of half of the drawing, but I need to decide how might I classify those two angles. Okay? Alternate exterior angles. Yeah, they're on the outside. So to decide which two lines are parallel, okay, you have to decide, okay, they're on the exterior of what two lines? Because those are the two lines that are the parallel lines. What two lines are creating the exterior? P and Q. So P and Q are parallel because of the converse of the alternate exterior angle theorem. Okay, the converse. Remember, the converse proves that the lines are parallel. Okay? Questions on one or two? Okay, the next few examples are going to seem kind of familiar because it's almost the same thing we did last week. I think the questions are just kind of posed differently. So number 3, we want to find the value of x to make L parallel to M. So number 3, let's draw two horizontal lines like this. This is going to be L and M. So what we're trying to do is we're trying to find what would x need to be to make these two lines parallel. And we're going to have a transversal cut through here. And let's make this angle up here 55, and then this angle down here 3x minus 2. So what I'm trying to do is I'm trying to figure out what would x need to be to make these parallel. Now, if these lines were parallel, what would I know about these two angles? 4x minus 2 would equal 55. So we'd set them equal to each other, add 2, we'd get 3x equals 57. Divide by 3, we'd get x equals 19. Good. So really it is kind of the same thing we did last week, just kind of maybe posing the question a little differently. Okay, number 4. This time let's draw L and M kind of going down a little bit. Okay, L and M, so those are the lines we're trying to make parallel. Okay, and then this is going to be a little complicated. We're going to go one that goes up like this. Okay, that one doesn't have a name. And then another one that kind of goes up and across the other way. So it's going to cross here like that. Okay, so we're trying to prove that these two lines are parallel. Okay, this big angle right here is going to be 119. This angle down here is going to be 4x, and then down here is going to be 40. Now, what I think is tricky about these ones is they actually try to trick you, and they give you too much information. They gave me plenty, right? I've got 119, I've got 4x, I've got 40, but I may not need all of this information, okay? So what I encourage you to do is don't feel obligated to use all of it, because then you're just going to make it more complicated, okay? So if I look at these angles, what I'm trying to do is I'm trying to see if I have a relationship between these. So you first might just want to kind of remind yourself where your parallel lines are. There's your parallel lines, okay? So if I look at these angles, that's kind of the transversal that they are all on, okay? What two angles, actually none of these have a relationship, do they? None of them are alternate interior, alternate exterior, anything like that. But some of them are close. Anybody have a game plan here? Grant? Okay, that's equal to 4x. How do you know that? That's a corresponding angle. Good. How will that help me do my next step? Good. 119 plus 4x equals 180 because they are a linear pair. So notice I don't really need that 40. Okay? I don't need to use it. All right? So if I subtract 119, we should get 4x equals 61. Divide by 4, that gives me 15.25. Okay, let's do one more of those. That maybe has a little too much information there. Okay, so number 5. Okay, this one's got a line going across this way, and then we're going to have L and M going up and to the right. Keep in mind those are supposed to be my parallel lines. Okay, and then we're going to have another line going up there. There we go. And this time, this angle here is 85. This is 110. And this is 4x. So once again, you might need to kind of remind yourself, here's my parallel lines. Which of these angles have a useful relationship, or which of these angles am I going to use? The 4x and the 110. And actually, it's going to be the same thing as we did last time. I mean, right? If this is 4x, this is 4x. So 4x plus 110 would equal 180. They're a linear pair. So 4x would equal 70. So x would be 17.5. Okay, last one, last 3 problems, we're going to use the same diagram. One more diagram, okay? So we're going to give a diagram. I'm going to tell you some information about some congruent angles. We're going to decide, kind of like we did on the first ones, which lines would be parallel. So let's draw A and B going up and across this way, A and B, and then we'll do X and Y going across here. And we're going to label every single one of these angles. We're going to keep it simple. We're just going to go across. So we'll go 1, 2, 3, 4. Start over at the left. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. They got all of our angles labeled. Just numbering across and start over at the left. Okay, so this is going to be like the same thing we did on the first two problems. So I'll give you some information. We're going to use that information to decide which of these lines would be parallel. Justify your answer with a theorem or a postulate. So number 6, let's say angle 1 is congruent to angle 14. Angle 1 is congruent to angle 14. So kind of like we did on the first ones. How would you classify angles 1 and 14? Alternate exterior angles, and they are exterior of which lines? X and Y. So I could say that X and Y are parallel because of the converse. Remember, if you're trying to prove the lines are parallel, it's the converse of the alternate exterior angle theorem. Number 7, what if I tell you angle 7 is congruent to angle 5, and angle 7 is congruent to angle 5? How would you classify angle 7 and 5? They're corresponding. Okay? Now, if they're corresponding, remember they have to be in the same location in a different intersection of the parallel lines. What would the parallel lines here be? It'd be A and B. See how they're in the bottom left of A and B? So it'd be A and B because of the converse of the corresponding angles theorem. And number 8, what if I say angles 10 and angle 11 are supplementary? If angles 10 and 11, so I'm not going to mark them as congruent, maybe I'll circle them. So 10 and 11 are supplementary. How would you classify 10 and 11? And 11. Same side interior. Now, the last class had a couple questions about this one because they actually are interior of both sets of lines, aren't they? But you have to say, okay, they're interior of these lines and on the same side of a transversal. So if you try to say, okay, well, they are interior of X and Y, okay, but they're not on the same side of a transversal. You see that? Okay, they are interior of A and B and on the same side of the transversal Y. So the lines that are parallel are A and B because of the converse of the same side interior angle theorem.